What if light does not just take one path? What if it takes all paths at once? This simple yet profound idea changed physics forever. And the man behind it was Richard Feynman, not just a physicist, but a storyteller, a prankster, a bongo player, a man who loved to challenge how we see the world. Today, you will discover who Richard Feynman really was, beyond the chalkboard and equations. You will learn what his groundbreaking idea about light was, the discovery that made scientists scratch their heads. You will understand why this discovery didn't just rewrite textbooks, it reshaped how we understand reality itself. And you will see how this strange behavior of light is happening around us, right now, every second. Feynman grew up in a world full of rules, but he didn't like rules that didn't make sense. He had a curiosity that burned hotter than anyone else's. When other children were playing games, he was tearing apart radios, trying to see how the world worked from the inside. He once said that he could never resist the thrill of figuring out why something happened. This curiosity would later lead him to the deepest mysteries of nature. He went on to become one of the most influential physicists of the 20th century. He worked on the Manhattan Project, designing the first atomic bomb. But unlike others, he always questioned the moral and philosophical consequences of his work. And it was this same questioning mind that would uncover one of the strangest truths about light. The question that obsessed him was simple yet profound. How does light travel? For centuries, scientists thought they understood it. Newton thought light was made of particles. Huygens said it was a wave. But Feynman asked the question no one else asked. What if both ideas are incomplete? What if light doesn't choose just one path, but explores every possibility at once? This idea seems almost magical, like science fiction. But Feynman showed that light literally does explore all paths. From the moment it leaves the source to the instant it reaches your eyes, it simultaneously takes every possible route. Some paths are straight, some zigzag, some loop in ways we cannot imagine. The path light appears to take is simply the one that is most likely, the one where all the possibilities interfere to create what we actually see. To explain this, Feynman developed what he called the path integral formulation. Every path has a probability, and all these probabilities add together to create reality as we experience it. This is not just math, it is a new way of looking at the universe. It means that at the deepest level, the world is a symphony of possibilities, constantly overlapping, constantly interacting. Reality is not a single line. It is a tapestry of paths, and light is the most faithful messenger of this truth. But there's more. Feynman had a gift for teaching this impossible idea. He used stories, diagrams, humor, and even cartoons. He didn't just want people to memorize equations. He wanted them to see, to imagine, to feel the universe with their own minds. He famously said, "What I cannot create, I do not understand." He built models, explained them in classrooms, and even drew pictures on the blackboard in ways that made abstract concepts tangible. Feynman's discovery doesn't stay locked in laboratories. It explains phenomena we encounter every day. The way light bends around corners, the patterns in soap bubbles, the colors of a sunset, even how lasers work, all of it makes sense through the lens of his path integral idea. And yet, despite its profound impact, very few people truly understand it. Most just see the world in straight lines. Feynman taught us to see the universe in all its tangled, beautiful complexity. And there's a hidden drama here. Feynman's ideas weren't immediately accepted. They challenged centuries of assumptions. Colleagues were skeptical. Journals questioned the math, but he persisted. And that persistence, combined with his playful curiosity, changed the course of physics forever. Today, quantum mechanics, quantum computing, and even our understanding of light in nature rest on his insights. Feynman also had secrets and stories you won't find in every biography. He was a safecracker, an artist, a raconteur. He played the bongos in Brazil. He drew cartoons that explained nuclear physics. And he once famously convinced a group of scientists to chase him across a hallway for a prank involving a metal ball. These stories show the man behind the equations, fearless, curious, irreverent, and endlessly creative. In this video, you'll uncover not just the equations and experiments, but the very mind of Richard Feynman. You'll see how one person's curiosity can change the world. You'll witness a discovery that is both elegant and mind-bending. Light does not take a single path, it takes all paths This changes everything from how we understand nature to how we imagine the universe itself. By the end of this video, you will not only understand Feynman's path integral theory, but you will see light differently. You will see the world differently. You will understand why physicists still revere him, why students still watch his lectures decades later, and why his insight remains one of the most profound in modern science. So, if you are ready to think differently, to question what seems obvious, to follow light along every possible path, stay with us until the end. We'll dive into Feynman's life, his discoveries, his stories, and the strange, beautiful logic of the universe he revealed. Welcome to Feynman Flux. Make sure to subscribe, because here curiosity is not optional, it's the path to understanding everything. Have you ever met someone whose curiosity was so boundless that it changed the way we see the world? That was Richard Feynman. He wasn't just a scientist, he was a thinker who could make the invisible visible, the complex simple, and the impossible imaginable. Born in 1918 in New York, Feynman grew up in a world full of ordinary rules, but he always had a way of seeing past them. While other children were content playing games, young Richard was tearing apart radios, clocks, and anything he could get his hands on. He wanted to see how the world worked from the inside out, and nothing could satisfy him more than uncovering the hidden patterns of nature. Feynman became one of the most brilliant minds in American physics. He specialized in quantum mechanics, a branch of science that even today feels more like magic than reality. He spent his life asking questions most people never even think of. How does light travel? How do particles interact? What is the most fundamental way to describe the universe? His answers weren't just clever, they were revolutionary. He worked on problems that defined the 20th century. During World War II, Feynman contributed to the Manhattan Project, helping to develop the atomic bomb. But he was never satisfied with just following instructions. He always asked why, always sought understanding. This relentless curiosity wasn't limited to war or equations. It touched every part of his life. He played the bongos in Brazil, drew cartoons to explain nuclear physics, and even cracked safes at Los Alamos just for fun. Curiosity for him was both a tool and a way of life. Feynman won the Nobel Prize in Physics in 1965, an achievement that recognized his groundbreaking work in quantum electrodynamics, the theory that describes how light and matter interact. But the Nobel doesn't capture the full story. What made Feynman extraordinary was not just his discoveries, but the way he communicated them. He had an unparalleled ability to take the most abstract and intimidating ideas and make them graspable. He turned chalkboards into canvases of imagination, diagrams into storytelling, and equations into visual maps of the invisible world. Students around the world still study his lectures, not just for the math, but for the way he made understanding physics feel almost inevitable. Before Feynman, the scientific community struggled with one fundamental question: how does light travel? Classical physics presented a contradiction. On one hand, light seemed to act like a wave, spreading out, bending, and interfering. On the other hand, it behaved like a particle, traveling in discrete packets of energy, arriving in bursts. Scientists could explain some phenomena with waves, others with particles, but a full picture remained elusive. Feynman asked a question no one else had framed quite like that. What if light doesn't choose? What if it doesn't have to be just a wave or just a particle? What if it explores all possible paths at once? This question was deceptively simple, but it led to one of the most profound insights in modern physics. Feynman introduced the idea of the path integral, a new mathematical framework that allowed scientists to calculate how light behaves by considering every conceivable path it could take from one point to another. This was not just a theoretical trick, it was a revolution. It meant that light, and in fact all particles, do not follow a single predetermined route. Instead, every possible path contributes to the outcome, and what we observe is the result of a vast invisible sum of possibilities. Feynman's work didn't just solve a puzzle. It transformed how scientists think about reality. Before him, light was a concept trapped between conflicting models, partially understood through approximations. Feynman gave it clarity, precision, and a visual logic that made it easier to imagine and calculate. His methods allowed physicists to predict behaviors that were previously impossible to understand, from the way electrons scatter to the phenomena of quantum interference. Suddenly, what seemed mystical or paradoxical became something concrete, something you could draw, compute, and reason about.
But Feynman was not just a master of abstract thought. He had a unique way of teaching and explaining his discoveries. He believed that true understanding required imagination, and he often encouraged his students to think visually, to build mental pictures of phenomena instead of just memorizing formulas. He would take complicated concepts and strip them down to their essence, using simple analogies, playful diagrams, and storytelling. To him, physics was not a set of rules to memorize. It was a puzzle to explore, a challenge to think through, a universe to interact with.
Even the most experienced physicists found themselves captivated by his approach. Feynman diagrams, which he created to represent interactions between particles, are now a staple in quantum physics. These diagrams are elegant, intuitive, and surprisingly easy to follow. They transform the way scientists calculate interactions in quantum electrodynamics and are still used in research today. His diagrams are a perfect example of how he could take something mind-bending and make it visually accessible, turning an abstract forest of equations into something you could actually see. Feynman's personality was as distinctive as his intellect. He had a sense of humor that was fearless, playful, and sometimes mischievous. He loved riddles, puzzles, and practical jokes, and he brought this same joy into his scientific work. He would challenge conventions not just to be contrary, but because he genuinely wanted to understand the rules beneath them. He questioned assumptions that others took for granted, and in doing so uncovered truths that reshaped physics. Feynman's contribution to our understanding of light and matter goes far beyond the classroom or the laboratory. It gives us a way to see the universe that is both rigorous and awe-inspiring. When you observe a beam of light, it is not just traveling from point A to point B. It is exploring countless paths, interacting, interfering, and shaping the world around it in ways we can calculate but cannot fully visualize. Feynman's brilliance lies not only in recognizing this, but in creating a method to describe it mathematically, to bring the invisible into comprehension. He also inspired generations of physicists, not just through his discoveries, but through his approach to learning and problem solving. Feynman encouraged curiosity without fear, creativity without constraint, and rigor without losing the joy of discovery. His life and work show that science is not just about knowledge, it is about wonder, exploration, and the courage to see the world differently. Richard Feynman made complex physics accessible. He gave us the tools to understand the subtle dance of light and matter. He showed that even the strangest phenomena can be understood if we approach them with imagination, patience, and the willingness to question everything. His work on quantum mechanics, his Nobel Prize-winning insights, and his path integral formulation continue to influence physics today, shaping how we study the microscopic and the cosmic, how we calculate the impossible, and how we imagine the invisible paths of reality itself. And yet Feynman was also a human being who delighted in life's curiosities, who played the bongo drums, who drew cartoons to explain physics, who pranked his colleagues, and who found joy in every question he asked. His legacy is not only the equations and diagrams, but the way he inspired people to think differently, to embrace uncertainty, and to pursue knowledge with playful determination. Before Richard Feynman, light was trapped in a debate between particle and wave. With him, it became a story of possibilities, a tapestry of paths, a phenomenon that could be visualized, calculated, and imagined. He didn't just answer the question of how light travels. He transformed the very way we think about travel, movement, and reality itself. Have you ever wondered how light really travels? You might think it just moves in a straight line from one point to another, but Richard Feynman showed us something far stranger and far more fascinating. In his revolutionary work on quantum physics, Feynman proposed that light doesn't pick just one path. Instead, it explores every possible route between 2 points. This is the heart of the Feynman path integral. Every possible path contributes to the outcome. Some paths strengthen the signal, others cancel out. In the end, what we actually observe is the most likely path. It's like a hidden conversation between countless possibilities, all happening at once, forming the behavior of light we see. Imagine it like running from your home to school. You could take dozens of routes, winding through streets, shortcuts, alleys, and even detours. Most of these routes are inefficient. They don't really matter. Only the quickest, most direct paths end up making a difference. Light behaves in the same way. All paths exist in theory, but only the paths that constructively add up determine what arrives at the destination. Feynman's insight completely changed how we explain quantum physics. The Feynman path integral doesn't just describe light, it provides a way to understand particles, forces, and the fundamental rules of nature. It shows that the universe is not a single line from point A to B, but a vast network of possibilities, all interacting in ways we can calculate and imagine. This is quantum physics explained in its most elegant form, light, matter, and reality itself as a sum of infinite paths, revealing patterns that classical ideas could never capture. And with this understanding, we begin to see how light travels not just as a particle, not just as a wave, but as a dance of probabilities shaped by every potential route it could take. Before Richard Feynman, our understanding of light was surprisingly limited. Classical physics treated light as a wave, spreading smoothly through space. It could explain rainbows, refraction, and interference patterns, but it failed spectacularly in certain experiments. One of the most famous was the double-slit experiment at low light. Particles of light, or photons, seemed to interfere with themselves in ways classical theories could not explain. Scientists had the math, but not the intuition. The answers were there, but the picture was missing. Feynman changed everything. With his revolutionary approach, he brought quantum electrodynamics, or QED, into the spotlight. Quantum electrodynamics overview is essentially the study of how light and matter interact, not as certainties, but as probabilities. Every photon, every electron, every particle doesn't just take one path, it explores a landscape of possibilities. Feynman's genius was in creating a framework that made these probabilities calculable, visualizable, and even intuitive. His diagrams and path integral methods turned abstract math into a tool anyone with curiosity could follow. The impact on modern physics was staggering. Experiments that had once puzzled scientists now made perfect sense. QED allowed for predictions of incredible precision, from the behavior of electrons in atoms to the scattering of photons in particle accelerators. Today, these calculations form the foundation of particle physics and countless technologies we rely on, from lasers to electronics. Feynman's breakthrough didn't just solve problems, it reshaped the way physicists think about the universe. Instead of seeing the world as deterministic and linear, we see it as probabilistic and interconnected. The quantum world is a place of possibilities, and Feynman showed us how to navigate it. His work in quantum electrodynamics made light, matter, and even reality itself more understandable, predictable, and astonishingly elegant.
Have you ever wondered why light always seems to take the straightest path from one point to another? At first glance, it feels obvious, almost boring. But Richard Feynman revealed a hidden story behind that simplicity. In reality, light explores every possible route it could take. Every twist, turn, and detour exists in theory. Each path contributes to what we eventually observe.
This is the essence of the sum over all histories idea. Imagine it like light sending out tiny possibilities, trying every route at once. Some of these possibilities reinforce each other, building up a strong signal. Others interfere in ways that cancel each other out completely, leaving no trace. What remains is the path we recognize, the straight line we assume light must take. It's not that light ignores other routes. It's that all the messy, improbable paths cancel themselves naturally. In very simple language, light doesn't just travel. It experiments. It explores. And through this quantum dance, what appears as a simple, direct journey is actually the sum of countless possibilities. This makes it easier to understand how photons travel, not as rigid particles, not as abstract waves, but as entities following a pattern of probabilities. Feynman's intuitive quantum explanation shows us that the straight path is just the most likely path, the result of a universe where all other possibilities exist and then vanish. This framework also explains everyday phenomena, from why shadows have sharp edges to why mirrors reflect light perfectly. Even the seemingly mundane behavior of light is a story of countless histories, adding up and canceling out, creating the elegant simplicity we perceive. Feynman transformed this counterintuitive idea into a mental picture anyone can imagine, showing that quantum mechanics isn't just abstract math, it's a way to see the invisible rules that guide how photons travel. Have you ever noticed how a straw looks bent in a glass of water, or how mirrors create perfect reflections? Richard Feynman's ideas about light explain exactly why. The bending of light, or refraction, happens because light explores all possible paths, and the paths that add up most constructively create the effect we see. When light passes from air into glass or water, the most likely paths shift, causing the familiar bending we call refraction. Mirrors work similarly. Light doesn't just bounce neatly off the surface. Every possible path is considered, but the ones that reinforce each other align with the angles we recognize, producing clear reflections. This sum over paths approach explains not only why light behaves this way, but also why we see shadows with sharp edges, patterns of light and dark, and even the vibrant arcs of rainbows.
Feynman's framework turns everyday phenomena into a story of probabilities and paths. Refraction and reflection physics become intuitive. Light follows the routes that survive interference, canceling out all the unlikely paths. The world of light is no longer mysterious. What we see, the colors, the reflections, the bending, emerges naturally from the quantum rules he revealed, showing how the invisible logic of light shapes everything around us. Richard Feynman's discovery gave us a completely new way to understand light. It went far beyond classical thinking, showing that light doesn't just travel in a straight line or behave simply as a wave or particle. His work helped form the foundation of modern quantum physics, giving us tools to predict, calculate, and imagine the invisible paths light takes every moment.
Next time you see light bending through water, reflecting off a mirror, or colors mixing in a rainbow, think of all the hidden paths it could have taken, all the possibilities adding up to create the world you see. Feynman showed us that even the simplest phenomena are filled with wonder, complexity, and elegance. If you want to dive deeper into Richard Feynman's ideas, explore how light really travels and see quantum mechanics explained in ways that simplify even the most complicated physics, you're in the right place. If you enjoyed this journey through light and discovery, make sure to like this video and subscribe to our channel Feynman Flux so you never miss another glimpse into the mysteries of the universe. Richard Feynman, Light Travels, Quantum Mechanics Explained, Physics Simplified. These are not just concepts, they are keys to seeing the universe in a whole new way.